Hi everyone, and welcome to today's event. We're delighted to have you here on Hopin, where you can enjoy networking sessions and fun activities throughout the event. In order to get the most out of Hopin, let's check out some of its key features. On the left-hand sidebar, you'll see several different icons. The camera icon, where you are now, is the main stage. This is where all the sessions will take place. You've likely noticed the handshake icon. This is our networking area. Here, you can connect on a one-to-one basis with another participant who's already in the networking area. On the right-hand side of the screen, you'll find interactive functions that you can use throughout the session. First, our speakers may also use polls and Q&As, so please participate in those when prompted. And finally, for those who would prefer to listen in another language, we'll be offering translations in the languages shown on screen now. Please click on the Translation tab to listen to the audio track in your preferred language. Now, let's get started with today's agenda.
Pani, and welcome back to the LATAM Apps Week live sessions. I'm Jessie Servin from the Google Play LATAM team. I hope you've been enjoying the content so far. Before we start, a couple of reminders. As you might know by now, we have an option of live translation to Portuguese and Spanish. You can find it on the right side of the player. You will also find a Q&A tab where you can ask all your questions. Our team will be monitoring to answer them during the sessions or afterwards. We also count with a help desk. If you're presenting any issue, please feel free to reach out. It is on the left side of the player. Well, in the last couple of days, we've learned about all the new features, things to come, and best practices to prepare apps for 2022 and engagement and monetization. In this track, Developing for Success, we will cover topics that will help you level up your app's development. For today's agenda, Slava will give us an overview of Android 12. Right after, we will discuss the best practices to achieve app quality with Steven. And after the break, Melissa and Andrew will show us how can you improve your app experience. Without further ado, I welcome Slava Panasenko from our developer relations team. Slava, I'll give you the mic.
Hi, I'm Slava Panasenko. I've been working on Android release and app compatibility for a couple years now. I hope you're excited about Android 12 we released last month. In this session, we will talk about the biggest compatibility challenges in Android 12 and share tips on how to give your users a smooth transition into this latest release. While there are a ton of changes and new features in Android 12 to explore, we recommend to start by testing your current app and releasing a compatible update first. As people update their devices to Android 12, this ensures a basic but a critical level of quality that ensures users have a good app experience. At the end of this talk, we'll share some of the stories from other developers and their tips and recommendations how you can do the same in terms of improving your apps. Let's start by learning about key platform changes in this release. As you may know, there are two types of compatibility changes, those that affect all apps running on new Android release and those that only affect apps based on target SDK level. To make it easier, you'll see the target API level badge in the corner of the slide for those changes that only affect newest Android 12 SDK. Android 12 introduces the biggest visual refresh powered by new personal material design. We have focused on simplifying and polishing existing experiences and helping you to build beautiful, secure, and performant apps tailored to user needs. To bring these changes, we've centered our efforts on three main areas: user interface, performance, and privacy. In this talk, we will cover Android 12 changes related to user interface and performance. Let's continue with UI changes to give a consistent and intuitive app experience. We've made changes to improve app responsiveness. So starting in Android 12, the system always applies default splash screen on both cold and warm app starts. Such splash screen is constructed using your app's launcher icon and the window background of your team. The new experience works out of the box on all apps running Android 12. However, if your app uses a custom splash screen, you'll need to migrate to new splash screen APIs. We encourage using Jetpack Splash Screen Library to enable backwards compatibility and create consistent look across all Android versions. Sorry for the hiccup. The new app splash screen are fully customizable, so we recommend removing your existing splash screen activity altogether, and if it's used for routing as well. In this way, you will avoid duplicated splash screens. There are actually different techniques for doing that, and we recommend you to go and read it on our developer website in the migration guides that we build to help you to migrate to new splash screen APIs. Android 12 changes the appearance and behavior of fully custom notifications as well, making them visually consistent and easy to scan with discoverable and familiar notification expansion for the users. Previously, custom notifications were able to take a whole real estate of the notifications and use their own layouts and styles. For apps targeting Android 12, notifications with custom views will no longer use full notification area. Instead, the system applies a standard template. This template ensures the custom notifications have the same decoration and as other notifications in all states, such as icon, app name, and expansion and collapse state affordances. The changes affect apps that define custom subclasses of notification.style or which use notification.builder methods to set custom content view. If your app is using fully custom notifications, make sure to test and check out how they look with this new template on Android 12. Android 12 also consolidates existing behavior to make it easier to perform gesture navigation commands while in immersive mode. All the previous existing behaviors for immersive experiences are now deprecated. They're replaced with the default behavior that allows users to perform gesture navigation commands only with one swipe instead of 2 swipes required on Android 11. If you're developing a full-screen gaming experience, you can still protect users from accidental gestures in sticky immersive mode by using a dedicated flag. Now, let's dive through app experience that affects perceived app performance and actual app performance for all users. Foreground services are great tools that allows Android system to ensure resources for completing long-running, user-initiated tasks at high priority. However, they're often misused. We found that almost half of the foreground services are launched from background, which leads to many issues, including those related to battery drain and user confusion when a user sees an unexpected foreground service notification. Hence, starting from Android 12, we will disallow starting foreground services from background and restrict launching foreground services to visible activities and user actions. There are less common use cases, such as handling certain broadcast receivers or companion device manager apps. For the full list of exemptions for foreground services, check out documentation on our developer website. Earlier this year, we introduced Expedited Jobs as part of Work Manager Jetpack library. These are low-latency jobs that can be invoked from either foreground or background to be executed right away. They can run during low-power modes, and we encourage developers to use them instead of launching foreground services when possible. In most cases, apps should use inexact alarms, which have the advantage of being battery-friendly. For special cases, like alarm clocks and timers, you can use exact alarms. In Android 12, we're adding a new manifest permission to give users visibility and control over the apps that use this permission. We added a new API to let you check the status of your app permission. Now let's talk about App Startup. For users, App Startup is important so they can keep focused on their task. Therefore, in Android 12, we're introducing new features and some changes in behavior for App Startup aimed at making users productive and happy. We have already covered new splash screen animations, and now we'll cover a couple more changes, starting with notification trampolines. Some apps use intermediate components, such as broadcast receivers or services, when handling user taps on notifications. Those are known as notification trampolines, and they often lead to delays and interrupted user flow. Apps targeting Android 12 and above won't be able to start activities from those trampolines. This new restriction helps reduce latency for apps started from notification. We encourage you to move away from notification trampolines and start activity directly from notification. For example, the Google Photos app now launches 34% faster after moving away from notification trampolines. If your app uses notification trampolines, use the following ADB command to see which component was launched when the user tapped on a notification. Android supports the notion of app links that lets HTTP URLs be directly linked to an installed app, bypassing the disambiguation dialog entirely. They improve user experience by removing friction from user journeys. App links are different from deep links in that app links can only handle HTTP schema, while deep links can cover any schema. Probably the most important Android app links behavior change is that, unlike previous version, Android 12 will always open the default browser for non-verified links. Now, Android 12 also introduces link-by-link verification. So if you have any server-side implementation or integration or configuration issue, errors will be limited to links that don't pass verification. New Domain Verification Manager APIs let you check for domain verification status, and if needed, take the user to settings for them to approve those settings for your app. You can learn more about app links and site verification on our developer site. Now that we learned about new features and changes in Android 12, let's look at testing and tooling to make your apps compatible. In Android 11, we introduced compatibility framework tools to make it easier to test and debug your apps against changes. With these tools, you can turn on and off breaking changes individually and evaluate how those changes impact your app. In this way, you can isolate and test against only one behavior change at a time, or easily enable changes behind Target SDK. You can check which behavior changes are currently enabled using the developer options, or logcat or ADB comments. For each behavior change, the first time when API is called, the system outputs a logcat message like this. You can identify all compatibility changes known to the system and their current overrides using the following ADB comment. Each change in the list has a name, change ID, reference, and whether it's enabled or disabled. ADB command can also be used to toggle changes on and off for certain packages. So in this way, there is no need for you to change target SDK version and recompile your app when you're testing platform compatibility. And because those changes are individually toggleable, you can isolate, test, and debug behavior change one by one. And also, when you're testing those changes, it's important to remember that they're only applicable for debuggable apps. So if you don't see your app in the list of in the compat console, you double check if the app is debuggable or not. In addition to that, Android 12 adds new ADB commands to test and validate app links for your applications, so you can use this command to verify your links manually or add them to your continuous integration toolchain. Also, make sure to try Android Studio Arctic Fox, because we added a lot of new link checks and warnings to help you test your permissions for many changes introduced in Android 12. And now we will talk about some of the stories from developers who already adapted to Android 12 changes. Vsync HealthMate app allows users to connect and sync Vsync devices over Bluetooth. Android 12 introduces new permissions that decouples Bluetooth scanning from location permissions. Location permissions and their relation to Bluetooth are difficult to explain to users from the privacy standpoint. For a few years, Vsync's team had to invest into topics and tutorials to educate users about why the app needs location permissions to scan for Bluetooth devices. And even with those investments, they still had negative reviews for asking for location permission to scan for companion devices. Nearby device permission, in a way more effective, as it asks permissions only for scanning and connecting. A couple tips from Vsync's engineers. First, abstract logic for checking and requesting permission. That helps to control entry points and minimize testing effort. Second, unit test all the permission checks on all supported Android version. And third, use actual Android devices and test different upgrade scenarios to ensure that app behaves correctly. To reduce user friction, nearby device permission will be granted automatically when a user upgrades to Android 12, but only if the app already had location permission granted on the previous Android version. To use a new nearby device permission for scanning, you must declare Bluetooth scan permission in your manifest file. This is a runtime permission, so in addition to adding it to manifest, you need to check it and request it in runtime before initiating discovery. By declaring user's permission flag attribute as never for location, developer indicates they don't intend to use scan results to derive user location. And if you need to only connect to Bluetooth devices, you can declare Bluetooth Connect permission. Let's look at one more change that we haven't previously covered, stretch over scroll effect. Most of the apps will have this effect working out of the box on Android 12. However, some Android 12 beta users noticed a strange issue when scrolling through their message in Signal app. In Signal's case, the app supports custom backgrounds, and the app uses a masking algorithm that basically punches through the screen. Whenever the contents are laid out or scrolled, the Signal app would build a list of the projections of message bubbles on the screen, and then use these projections to apply a mask with a given gradient or solid color. The team at Signal was quick to come up with a solution using recycler view.item decoration. Fixing the overscroll issue early lets Signal app deliver the experience people expect on the new devices without compromising performance. A couple tips from Signal team. Pay attention to blending modes and how they work with additional layers on Android 12. Android 12 Overscroll uses an additional layer to render the stretching effect, and that can generate different results with various blending algorithms. Another important point is to ensure that the background is rendered by Recycler View. Do a thorough QA and address beta user feedback for Android 12 compatibility ahead of the release. Signal app is a great example of delivering delightful user experience. Luckily, the Signal private messenger for Android is open source, and you can check out their fix on GitHub. Let's recap. In this talk, we tried our best to cover the most important changes in Android 12, and there are more changes, and we encourage you to check those changes at developer.android.com. Most importantly, we would like to remind you to test your apps and confirm compatibility with Android 12. Many developers already did it, and it's now your time to check and verify your apps. We can't wait to see what you can do in Android 12, and we hope you get your apps ready. Thank you. Obrigado pela sua atenção. And now I'm going to pass it to Steven.
Quality for new platforms and initiatives on Android. Today, I'm going to talk to you about overall app quality, why it's important, and what to think about when trying to improve your app's quality. So, why should you care about app quality? Well, we ran some analysis on some apps and games on the Play Store, ranking their quality scores and analyzing their performance, comparing the average quality title to an app that is good in quality. We saw a 7x increase in retention and a 6x increase in spend when comparing average to good. Developers can also glean a lot of information from user reviews. Negative feedback tends to mention problems with stability and bugs, whereas positive reviews often mention performance, design, or usability as a reason for their satisfaction. Your app can have really great features and functionality for your user base, but if there are issues with stability or usability, it can be hard to convince users to stay with your app and regularly engage with it. When thinking about quality, we often think about these areas. Does the app have features that users value? Like, can they be productive or build communities? Can they have fun? Does the app have a great design that is intuitive and delightful to use? Is the app performant and widely available? And finally, does the app take advantage of the latest Android features to enable all of these things? All of these areas, in addition to other factors, can affect visibility and discoverability on the Play Store as well. There are tons of resources on the Play Academy that can help dive deeper into these areas to help developers through the development process, so please take advantage of them. Let's now dive into design and how it's important as a factor in the perception of app quality. Android users have certain expectations when it comes to apps navigation flow, how UI components work, and to an extent, what those components look like. Material design provides a cohesive and consistent framework for interfaces. While not required, we do encourage developers consider it. It's meant to be cross-platform to help minimize development times and provide a consistent, cohesive user experience across form factors. It's also worth noting that alongside the release of Android 12, Google also released an update to Material Design called Material U. This new revision aims to provide a more custom feel with updated theming, widgets, additional animations. So consider looking into all of the updated components and options when thinking about optimizing your app's design. One of the benefits of improving app quality is its effect on app discoverability. The Play Store tries to surface content that is relevant and of high quality to users who would be interested in that sort of content. One key area that can impact discoverability is around engagement, content, and features. And a way to really separate your app from the rest is by having unique features or class-leading implementations or approaches to a genre or a functionality. This could be amazing polish or visual design, novel features, or just unique content. You can try these features out by leveraging Play Console features like closed and open betas to gather feedback from your most engaged users. Additionally, the Play Console provides performance data that you can use to compare your app's performance to peers in order to identify problems as they arise or before they arise. Another factor in affecting discoverability is around app performance and stability. One of the key areas for technical performance is around Android Vitals, which provides data on how your app performs with your user base. And this can all be found in the Play Console. Vitals covers 4 main areas: battery, stability, rendering, and app startup times. And the console itself highlights 4 core vitals: stuck partial wake locks, excessive wake ups, ANR rates, or app not responding, and crash rates. Rendering vitals are a measurement of how much jank users of your app are experiencing. Frozen or slow frames can be pretty visible and a source of dissatisfaction with your users. Startup times that are excessively slow can negatively affect a title's engagement and retention as well. It's important to monitor all of these signals, primarily the core vitals, as again, poor performance in those areas can have an impact on visibility in the Play Store. As an example of improving vitals that can lead to better business metrics, in a case study, Mercado Libre reduced their app size by 70% and their crash rate by half, leading to a pretty substantial increase in both the install rates and retention. And let's talk about some additional technical bits that can help improve app performance. Historically, apps on Android have used APKs and OBBs to deliver content to users at the time of download. But more recently, the app bundle has become the preferred method of distribution for Play. Today, new titles are required to be distributed this way, although existing apps can continue to use APKs and OBBs. But I want to talk to you about some of the key benefits of app bundles over the APK and OBB approach. The first big area is the modularity of app bundles. Based on device characteristics, different pieces of the app can be delivered to the user, decreasing the initial download times and eliminating the need to manually split builds for device configurations. Only the assets that are appropriate are downloaded and installed. For games, Play asset delivery, in addition to app bundles, allows for a more seamless download experience. What would have traditionally been part of an OBB at install time can be pulled down on demand as a fast follow or at install like normal. Similarly, for apps, feature delivery means that you can reduce the install times and install sizes by cutting out features that are not always needed, delivering them to users when users need to use those functions or features, removing any features or sections of the app that are no longer needed. For example, Netflix was able to reduce their app size by 33% by cutting out features from the initial install, such as the customer support actions. Only users that needed support would download this feature upon request. To reiterate, app quality is built upon a wide range of factors, and Play offers tools for you to leverage, like data and distribution options in the Play console, features like app bundles to allow you and your app or game to be dynamic and optimized on any device, vitals, which can help catch any problematic releases or device types, design frameworks like Material U that can help you create a unique and cohesive experience for your users, and new and exciting features in Android 12 that can help your app stand out and provide a comprehensive user experience. Utilizing these options can help you hone your app and deliver a unique, optimized, tailored experience that users engage with. Please use resources through developer.android.com, material.io, and the Google Play Academy to help hone your app experience. Thank you for your time. We'll be taking a short break now, and we'll resume momentarily with Melissa on her session about Firebase.
Breathe, your moment soon will come. Oh, and welcome back from break. My name is Melissa. I'm a software engineer working on Firebase performance monitoring at Google. Today, I'll be sharing with you how Firebase can help you run your app with confidence and help you create higher quality apps. As app developers and even as app users, we all know that high quality app experiences are fun and delightful, and poor quality apps can leave us frustrated, or at worst, they can be buggy or crash, blocking us from getting an important task done. But as developers, frankly, we know that it can sometimes be hard to make quality and app performance a top priority, especially if it means taking longer to ship a new feature out to customers. So sometimes teams have to weigh the costs and the benefits of adding a shiny new feature against enhancing the performance of an existing feature. And when you stack these two options up against each other, it's not uncommon for the shiny new feature to be the thing that wins out. But according to Google Play regarding app discovery ranking, apps that have strong technical performance and a good user experience are generally favored over lower quality apps. And when a user engages with a high quality app, they're more likely to stay engaged. So it's clear that there's value in making your app higher quality, but why is it so hard to prioritize? Well, the spoiler alert, we'll get to it more, but the spoiler is that the answer is because it's really hard to pull off. So if you ask me, what are some things that you need to do to be confident that your next new app or your app's next new feature will be high quality? Here's what I would suggest. Number 1, test your app on lots of different devices. Number 2, get your app in the hands of real people for testing. And number 3, understand how your app performs in the real world and then troubleshoot as needed. It seems really straightforward, right? Well, the problem with my suggestion is it doesn't really do a great job of acknowledging how hard each of these things can be. So first of all, manual testing is expensive. It's not very scalable. Not everyone has in-house QA teams, meaning not everyone has resources specifically dedicated to manually testing your features before they roll out. And then secondly, sending APKs and AABs around to run an internal testing program can also require a lot of manual work, and that too is hard to scale. And third, performance issues can be caused by virtually anything. So the scope of task number 3 here is actually massive. So for example, one of your dependencies could be having an outage that breaks an experience in your app suddenly. Or let's say that your app works great on your device, but on someone else's somewhere else in the world, suddenly there are some issues that you've never run into before. How would you even know about issues like that? So today, I want to talk about how Firebase can take away some of the pain from the challenges that I just described. Firebase has app quality tools to take a lot of the busy work and mystery out of the picture so that you can focus your time on creating great new experiences for your users. But before we dive deeper into these app quality tools specifically, let me take a step back and introduce Firebase as a whole. So Firebase provides a reliable and cohesive platform of tools and cloud services that help solve 3 core problems in your app lifecycle: managing your backend, testing and monitoring, and engaging users. Firebase's tools and services are designed to help you develop your apps faster, run your apps with confidence, and engage your users effectively. For the rest of the time that we have together today, we're going to focus on this middle challenge. We'll dive deeper into the tools that Firebase has to offer on the app quality front so that you can monitor your app's performance and stability, troubleshoot quickly, and of course, release with confidence. So to get started, let's bring back this list that I showed earlier about how to gain confidence in your app quality. What we're going to do is we're going to walk through how to accomplish each of these things with Firebase, starting with testing your app on lots of different devices. So let's imagine that you have an app, and let's say that for this app, your users like to use it on the go on their mobile phones during the day, but later in the day, they prefer to use a larger screen like a tablet to use their app once they're lounging around at home or something. For an app like this, testing across and designing to account for various makes and models of devices is an important part of meeting your users where they are. But as we mentioned earlier, doing a bunch of manual on-device testing yourself really isn't scalable. Having a setup like this on your desk, for example, isn't just messy and hard to manage, but also just like keeping track of and obtaining all of these devices itself is expensive. So ready to take on the challenge of making this simpler is Firebase Test Lab. With Firebase Test Lab, you can validate your app on both physical and virtual devices that simulate actual usage environments. So how does it work? Well, it's actually pretty straightforward. Google has production devices running in a Google data center ready to test your app to make automated testing on real devices way easier. So basically, you don't have to go to a store and buy a bunch of these test devices yourself because we already have them waiting for you, which is pretty cool. The easiest type of test to run with Test Lab is something called a Robo Test. A Robo Test requires no extra test code to run. Robo Test will intelligently crawl your app, pressing buttons and navigating screens to maximize it. You can also customize these Robo Tests. So for example, let's say that in your app, you require users to sign in, and only after that can they perform some meaningful actions. What you can do is you can have your Robo Test sign in using certain account credentials that you specify in order for it to appropriately test that use case. And then once your app is integrated with Firebase, you have access to the Firebase console, and the steps for getting started are really quite simple. First, upload an APK. Second, select the physical and virtual devices that you want to run testing on. You'll also have the option to select the orientation and locale of the device. And then third, you run the test, and then you look at your results, again, in the Firebase console. So let's take a look at what results might look like for a real test. So results for a Robo Test could look something like this. You'll be given a lot of information. We're not diving into it all in this demo, but it includes a visualized crawl graph showing you all the paths Robo took in your app. It'll also give you screenshots and videos of the full crawler experience. At the top over here, you'll even see that there's a performance and accessibility analysis right there. And when things go wrong, you're going to see something called test issues reported to you. So you can see that in my test app here, the crawler ran into a null pointer exception, which I can then let my team know about to investigate and then fix. So I wrote no extra code, and in just a couple of minutes, Test Lab's already giving me some pointers for things that me or my team might have missed while developing my app, which is pretty neat. But Robo Tests aren't all that you can run with Test Lab. We can also run customized instrumentation tests with Test Lab. So these are tests written by you that use the Espresso or UI Automator Android test frameworks. You can learn more about how to create and configure these types of tests at developer.android.com. So to review Test Lab, it gives us access to lots of information to analyze how our app performs on other devices. Screenshots, videos, stack traces. But automated testing still misses something critical. It misses context. So how can you test with real context? Well, the answer is by testing with real people. An automated crawler or an instrumentation test doesn't actually understand what users expect and what users will respond well to. We build apps for people, not for tests. At least I hope so. And that's why the second item on our list is particularly important: getting your app in the hands of real people for testing. So like we alluded to earlier, we mentioned that there's a lot of toil that comes with running a testing program yourself. There's the challenge of distributing your apps, but there's also the additional challenge of tester management and then figuring out how to troubleshoot when things go wrong. Firebase App Distribution is designed to allow you to easily distribute pre-release versions of your app to trusted testers to get valuable feedback before a new release is in production, taking the busy work out of distributing your app and delivering your distributions in a way that's friendly to your testers. So what does that all mean? So more concretely, instead of having to manually send all your APKs and AABs to testers, Firebase App Distribution lets you manage your whole internal testing program in one place. There are no required SDKs to install, no forms to fill out. You can distribute your APKs to testers instantly with no approvals required. There are several ways that you can distribute Android apps with App Distribution. You can use the Firebase interface, you can use Fastlane or your Fatal plugin. But another way is via Firebase console. To just show you how simple this process is in the Firebase console, so here's a screenshot. So say that I've already uploaded an APK to the Firebase console. I listed the emails of some testers that I want to include for internal testing. And now all that I have to do to get this in the hands of my testers is add some release notes right here that you can see that I filled in. And then it's just ready to get sent off to my list of testers with just a click of a button. So once I do that, well, what happens next from the tester's point of view? Well, your testers are going to end up receiving an email notification, this nice little email notification, that'll also give them the option to install the Firebase App Tester app. The Firebase App Tester app is an easy way for testers to manage all the distributions they've been invited to try out. making the tester experience delightfully simple so your testers can focus on testing and giving you feedback on the user experience without worrying about like clunky logistics. So let's say now that our testers have given us the gift of feedback on our app. Some of it's positive feedback, some of it indicates that things need to be improved. But let's say that some testers have let us know that the app has crashed shortly after they signed in. This is an example. So this is a data point that tells us a bit about how our app is behaving in the real world. But with this information alone, we don't have that much information to work with to correct the problem. We don't know why our app is behaving this way. Answering the why question really comes down to understanding, how your app is performing in the real world overall. So it brings us to the last item on our list to get us to a place where we can have high confidence about our app's quality. Understanding the problem at a very granular and technical level is our first step towards being able to troubleshoot and fix the problem, and then, of course, improve the user experience. When it comes to improving the quality of an app from a purely technical standpoint, there are two important pieces to understand. This is kind of an oversimplification, but I think it's a helpful place to start. The first is to understand where your app fails. In other words, where does your app completely crash and therefore no longer work for your users? To understand this, we need to understand the frequency of crashes, trends in crashes. We need context to help us understand what might have led up to a crash. The second is to understand where your app has bottlenecks. So one simple way of looking at this is, where is your app slow and why is it slow there? So some examples of things that are good to know: trends in app start time, metrics for network request responsiveness, the ratio of slow or frozen frames in your app. Things like slow screens or error-prone APIs are things that are going to make your app feel less refined when it's in the hands of a user. But once again, it's important not to underestimate the scope of this challenge. Crashes can be specific to things like certain devices, operating systems, or app versions. This applies to other type of technical performance issues too, which on top of that can even depend on geographic region or type of network connection. It's quite difficult to keep track of the wide variety of inputs that can contribute to different experiences for users of the same app. Moreover, having this many variables at play makes it extra tricky to understand what to prioritize and to understand what types of issues are going to yield you the greatest impact to improve your app for the most users if you choose to address it, right? So Firebase has two tools focused on making it easier to find and address quality issues in your app. The first focuses on crashes, and it's called Firebase Crashlytics. Firebase Crashlytics will help you track, prioritize, and fix crashes faster. With Crashlytics running on over 3 billion devices worldwide, which is nearly every capable mobile phone on the planet, Crashlytics offers unique insight into how your crashes might be affecting your app and what their underlying causes might be. Accompanying Crashlytics is Firebase Performance Monitoring. Firebase Performance Monitoring is all about giving you real-world, actionable insights into your app quickly so that you can reduce the time to resolution for issues in your app. To get started with Crashlytics or performance monitoring, you'll have to integrate the respective SDKs into your app. Once your app starts to send events to Firebase, meaning once your app starts to have some crashes or performance events, you'll know the integration was successful when you see data in the Firebase console. So to showcase the power of both of these products, let's take a look at another demo, and we'll start with Crashlytics, once again, in the Firebase console. So the first thing you'll notice on the Crashlytics console is this chart on the upper left corner titled Crash-Free Statistics. Crash-free users represents the users of your app that have not experienced any crashes in the time range that you've selected on the dashboard. This is your most critical metric for being able to quantify how crash-free your app is. But below, we'll get a list of issues prioritized by impact. We even get a preview right on the list of the line of code where the crash occurred. And if we drill into it, we'll have access to data from several sessions that experience this crash. It provides a full human-readable stack trace, more details about the type of exception that was thrown. We're also given more context about the device and OS for that particular session. So that was a very, very fast overview of Crashlytics' dashboard. But technical app performance doesn't just come down to being crash-free. A crash-free app can still be extremely slow and sluggish. This is where Firebase Performance Monitoring can come in. On the Firebase Performance Monitoring dashboard, you can customize your view to include the metrics that you know are most critical to your app. So these can be things like app start or a particularly important screen or some API calls. But some of the most important issues you should address might be the ones that you don't even know to look out for yet. So at the bottom of this dashboard, there's a table with all the performance traces collected by Firebase Performance Monitoring and some of their key metrics. So to prioritize and find something that might need your attention, you can sort the entries in the table in different ways. So for example, I can sort all network requests by response time to find my longest calls like I did here, or I can even sort them by delta, and this will allow me to sort by the greatest recent change. To drill into a metric more deeply, just click in and then we can start to understand how the performance of a given metric varies across attributes like app version, country, and more. To investigate even further, you can drill into sessions here too, to give you even more context into what was happening when a user experienced a low performance event. So that was a very quick overview of performance monitoring as well. But just to anchor us back in where we started, let's bring us back to our core question of what can we do to gain confidence in app quality? Well, to summarize what we've spoken about today, you can use Test Lab to validate your app on various devices so that you don't have to do this manually. App Distribution will help you distribute pre-release versions of your app to trusted testers so that you can get feedback from real people on the experience you created. To understand your app's crashes, Crashlytics is there to help you analyze and fix stability issues in your app that will eventually erode app quality over time. And Firebase Performance Monitoring takes it a step further to help you find and fix additional technical performance problems in your app with quick and actionable insights. All that said, I'd be remiss if I didn't mention that we really just scratched the surface of each of these Firebase tools. There are many, many more powerful features to take advantage of to take your app to the next level. So these are things like Test Lab game loops test, or additional tester management features with app distribution, things like velocity alerts and Crashlytics, or some of the custom offerings in performance monitoring like custom code traces and custom URL patterns, and so many others. I hope that you're eager to learn more and stay connected with us in the Firebase community. So tomorrow will be Firebase Summit. This is Firebase's annual conference, which is full of product updates, demos, and fun. You can register to attend at g.co/Firebase Summit. In addition, you can keep up with us all year round and learn even more about how to use Firebase for your app by subscribing to our YouTube channel and following @Firebase on Twitter. To learn more about future Firebase community events, check out our community page at firebase.google.com/community. That's all I have for you today. Many thanks for joining me. I can't wait to see your apps. Have a great rest of LATAM Apps Week. And next, I'd like to invite Andrew Fitzgibbon.
Hello, everyone. My name is Andrew Fitzgibbon. I am a developer relations engineer on the Flutter and Dart teams at Google. And so today I'm going to talk to you a little bit about this notion of responsive apps versus adaptive apps. And the reason is because these two terms are very similar. And there's some subtle differences between them that I want to talk through, and then look at a couple of examples of how to do this in Flutter. So the reason we're here, the reason we're talking about this is because there are screens everywhere. And there's some really small differences between each one of them, right? We might have foldable devices that have a hinge in the middle and two, maybe more screens. We have our normal phones that we can just touch and tap. And we might have web browsers that can resize, but they're on the web. They're constrained to the browser. We might have desktop windows that can go a little bit bigger. They're a little bit closer to the operating system, and so they have a few more controls. And maybe we have something that looks like a desktop window, but also has touchscreen capabilities, like a tablet or an iPad or something similar like that. And as programmers, it's tempting to utilize some of our common tools to handle these things, like the if statement. And it's really tempting to use this because we could say, if we're on platform A, do things one particular way. If we're on platform B, maybe it has a particular orientation and a particular size, and so we want to organize our things in a certain way. And maybe on platform C, we just throw it all away and restart altogether because we just need to restart and do something totally different. And this is kind of nice because we're able to separate out the individual concerns for each and every single one of these platforms. But then we have this if tree throughout our app. We have it in a bunch of different places, and it gets unwieldy and hard to maintain really fast. It also presents some potential questions here, because maybe on platform A, screen sizes vary quite a lot. For example, on iOS or Android, the range of different screen sizes we could have is enormous. We could have very small phones, or we could have very large phones that look kind of like tablets, but are actually kind of phones. And on platform B, some other platform, maybe we can resize and reorient the window. We're not just given a size and orientation. Those things might change. And maybe on platform C, maybe we actually have multiple screens and there's a hinge between them because it's a foldable device, but maybe actually it has another screen that we can use a stylus or a pencil on, and it just complicates everything. And so with this notion of saying, if we're on iOS, if we're on Android, if we're on web, if we're on desktop, and that long tree, we're actually combining multiple different ideas into one single thing. And so these two different ideas that we're actually talking about here are responsive apps, or responsive design versus adaptive apps. Now, again, these are very similar terms and often used in similar contexts, but they do mean different things. And here's how I think about them in particular. So everything has a screen, right? And that's kind of the point for UI frameworks, right? Is we have a screen and we want to show things to people on it. And in most UI frameworks like Flutter, putting things onto the screen is more or less the same everywhere. For example, maybe I have a blue button that is in the middle of the screen. It's centered in the body of our scaffold. And it has a particular color. It has particular text. It has some rounded corners. We've got another button in the bottom corner, a floating action button, which has a different text. It has different size. It has a different shape. And maybe for both of them, we say that in the material design sense, it has an elevation of 0. So they appear flat. Maybe we want to change it so that it has a little bit of a shadow. And from our perspective as developers, that's what we're doing. We just say, here's the button. Here's how it should show up. Put it there. But oh no, the screen size has changed. However, will we respond? So this is this idea of responding to different screen sizes. And in responsive design, this is the idea of changing the layout based on the number and orientation of the pixels. We have some kind of notion of how many pixels we have. We have some kind of notion of which way is up. And what should we do with that information to decide where things should be? Note that this is different than what platform we are running on. This is only restricted to what is the size and orientation of our pixels, and making our decisions about layout based on that. Okay, so that's all well and good. I mean, everything has a screen. We've discussed that a couple times now. Everything also has other things, because modern computers are more than just a processing unit to smash numbers together and store them somewhere. These modern computers also have things like longer term storage and networking and sensors, like maybe we have GPS antennas, maybe we have barometers, temperature, heart rate, biometrics. Maybe we have peripherals like keyboards and cameras and microphones and mice and secondary screens and tablets and other things, all added in to more than just a screen. So there's these ideas, these things, these sensors that we have to deal with that are a separate concern from how big is the screen and which direction is up. And so pretty much everywhere that Flutter can run pretty much is all of these things, but they're all the same in spirit. For example, maybe I want to get my current location. I would like to ask the device that I'm running on, where am I? And in return, get some latitude and longitude coordinates representing exactly where I am. Now, the spirit and intent of that is the same everywhere. I ask for my location, I get the location back. But the details involved, the exact details, vary pretty widely. Am I using a fused location provider, or am I using a core location manager on iOS? Or am I using something totally different because I'm on a totally different platform that names things just slightly differently? And this fundamental idea exists, and so we must adapt to try to figure out how to handle those. So this idea of adaptive apps is this notion of changing how we do something based on what's possible on the platform. So between these two ideas, we have this pretty clean separation of things. We have our UI and presentation layer. This is our responsive design. How do things appear? How do things on the app look? Versus the platform capabilities. What is possible on the platform, and how do we actually do that? How do we run something like getting our GPS coordinates? And so I want to look at a couple of tools in Flutter that provide these two different capabilities for you. And on the one side, in responsive design, and if you're at all familiar with web development, this is going to sound very similar, where we have this notion of a media query that tells you how much space you have to run your app, to draw your app on the screen. And in Flutter, we have the same thing. We pass it a context, we get a media query out, and we can get the size of the space that we have available to us. So with this, we have the ability to put in what are called breakpoints and determine, if I've got thousands of pixels horizontally, let's show a lot of information. If I only have a couple hundred, maybe I'm going to only show a little bit of information. And media query is really giving you that picture of the whole size that you have available and allowing you to make the decisions on what kind of layout you're going to do based on that size. Now, at a slightly lower level, you might want to say something like, well, I've got a widget and maybe I want to be able to change the layout a little bit more dynamically and a little bit more precisely at a smaller level. And for that, we have something called Layout Builder. Now, if you're at all familiar with Flutter, you might be aware or remember that constraints go down and sizes go up. And it's this idea of saying that a parent widget is going to tell its child how much space it has available, and then the child is going to return how much size of that available space it thinks it's going to take up. So in Layout Builder, there's this builder method that gives the child widget an opportunity to make some decisions about the constraints that are put in. So instead of saying, for example, I'm going to be a padding with 8 pixels on either side, and the container is 400 pixels wide, maybe I'm going to say, we've got these constraints of saying we only have 200 by 1,000 pixels or something like that. It could be any number. And based on that, I'm going to change which child widgets I'm going to do. So this is another opportunity for you to say, well, this particular widget or this particular subpart of the widget tree only has so much space available. And maybe it changes because it's a builder method and I can run it whenever things change. But given that space, I'm going to make some different decisions on my layout. Now, this is really helpful in cases where in common app design, you're going to have a list of things, say a list of songs or a list of playlists or a list of items in an e-commerce website. And when you click on those or you tap on those, it provide you additional details about that thing. And maybe you have some additional controls like your media play, stop, pause sort of controls or some kind of editing controls or something else that you want to display. And when you have a really small amount of space, maybe you're going to say, I'm just going to display the list and a little bit of extra helper things at the bottom. If I have a little bit wider, maybe I can also display some of those details. Maybe if I have quite a bit more space, maybe I'm going to display the details differently or provide those different controls in a different way. That's these two different ideas. So we've got media query, which gives you the size of the screen that you have available to paint, and layout builder, which is going to recall your builder method every time the size available to that widget changes. In some cases, and this is going to be a little bit of our transition into adaptive apps, but in some cases, a particular platform has a particular standard for how things appear. So for example, in iOS and Android, those two platforms have different ideas about which order the confirm and cancel buttons appear. This has nothing to do with how big the screen is, but it does have things to do with where and how things appear on the screen. And so for this, we recommend using theme.ofcontext.platform. And this enum, this set of constants is chosen based on which platform you're running on. So it could be iOS, Android, web, desktop, and a couple others. And this is your ability to say, I'm going to change how something is laid out, how something appears on the screen based on these high-level ideas of the platform. Again, this has nothing to do with how big the screen is and how much space you have. It's just saying on one particular platform, the convention is to put the confirm button first and the cancel button second, versus saying that they do things fundamentally differently. Now, I'll note that Flutter and Dart provide a different way, another way of accessing the platform. That's the is constants. So is iOS or K is web constants from a Dart.io.platform. And those are often used, but I distinguish the two in the same way that I distinguish responsive design and adaptive apps here in this talk. Dart.io.platform used for the determining capabilities, theme.ofcontext.platform for things that are actually shown to the user, like the order of the confirm cancel buttons. Okay, so we're kind of transitioning into this idea of the platform capabilities. And so I wanted to now talk about this idea of adaptive apps and how we account for that in Flutter. So one of the easiest ones to look through, if you have an opportunity to look through on your own time, is a package called URL Launcher. And it's a simple package where you give it a URL and it opens it. There's lots of videos like the short snippet here I've shown on the slides on the Flutter YouTube channel that go through this package in particular. So I'm not going to spend time talking about that one. But behind the scenes, it uses two different concepts: federated plugins and platform interfaces. So the first one, federated plugins, basically just helps us with the development process. Instead of one giant package that has a bunch of if statements to try to account for the different platforms, you have a single package up top that provides you the Dart interface that is going to be used by actual apps. And underneath that, there are separate apps for each one of these specific platforms you want to use. And underneath those is some kind of interface that lets Dart call the platform's APIs. In most cases, this is what we call a platform channel, where Dart is able to invoke methods from Kotlin, Swift, Java, or whatever the underlying language is for that particular platform. In other cases, like the web, for example, we use JavaScript interop via Dart HTML in order to actually call that platform code directly. So it's very conceptual. Let's look at a specific example. I've mentioned getting GPS coordinates a couple of times, and so let's look at a package that does that. This is a snippet from the Geolocator package. And when you just install Geolocator and look at geolocator.dart, this is what you get. There's not much there. There's some documentation, and for each one of the methods, it just calls out to this instance of something else. That's the entire package. There's one file, one class, and that's all it does. And so there's not much there. You know, we might have methods to get permissions. We might have methods to get our current location. But otherwise, we just delegate out to geolocator platform.instance, and that's it. That's the entire code for the package. But at build time, Flutter and Dart are going to go into the pub spec and say, okay, actually, we were asked to build an Android package. And so for that, let's go out and get this other package as well. So we've got Geolocator Android, which is another package we're going to pull in if we're building for an Android device. Same for iOS, same for web, same for desktop. And that package goes into a little bit more detail. So this is one of the fundamental classes in the Android Geolocator package. And here you can actually see it using, if you're at all familiar with Android development, the Fuse location provider, which is our common way of getting location on an Android phone or device. And in particular, this also implements the Geolocator's platform interface. So as a reminder, our federated plugins have a Dart interface up top, and that's our very simple list of methods that just call out to geolocator platform.instance. And then we have our our specific package. Here's our Android package, which is actually calling the fused location provider. And it is implementing this geolocator platform interface, which is in another package, the geolocator platform interface package. And this is also pretty high level, but gives our platform code something specific to implement. It's saying for our Dart, for our apps that are written in Dart, they're expecting to see things like get last known location. You, as a platform package implementing the fused location provider and actually calling it out to that provider, ought to also implement the get last known location so that the Dart app at the high level is able to call that. And so what this gives you is this idea of, from the app's perspective, you're able to just write Dart code. Not a single if statement, unless you're changing the order of your buttons on the confirm cancel dialog. But otherwise, there's not a single if statement saying, if I'm on Android, call the fused location provider. I'm just saying, use this package, and at build time, it's going to pull in the right platform's implementation. And so this is a really good way, a really solid way to say, for these different platforms where I want to adapt to different functionality, let's just pull in the right one and use that. And so that's more or less it. By keeping these two purposes separate, you can really avoid these messy if-else trees, but still respond to the various screen sizes and orientations, and as they change, respond to them appropriately, and also adapt to the different capabilities that the platform provides. And so that's my talk. I hope this has been helpful in learning about responsive design and adaptive apps. Thank you very much for your time. Gracias, obrigado, and I hope you have a great rest of your conference.
Hi, Andrew. Thank you. And actually, thanks to all our amazing speakers. It's been 2 days of great content. We hope these sessions and the content we share during this week will help you level up all your apps. Yes, the content does not stop here. In the next 2 days, keep an eye out for 2 on-demand videos that we will send on Wednesday and on Thursday. There will be some tips for user acquisition and the things you must know about Google Play. On Friday, we will send you a one-sheet summary for the event with articles and important link reference to all the content we presented in these 2 days. We know it's been heavy, so we are handing this for you. And remember that these events are built for you and by you. We care about your opinions, so please share with us your feedback. You will see a link pop out on the screen, so please click it and it will redirect you to the form. It will also be shared by email. Please send us your feedback. And last but not least, you know that our policies are essential considerations for the apps. So to have you all updated on the latest changes, do not miss a policy webinar that we're having on November 17th. If you haven't registered yet, please do so by scanning this QR code you're seeing on screen. And well, from the Google Play LATAM and the Google Play team and all the speakers, I thank you all for today, for yesterday, and for your participation. See you soon, and let's move forward together. Bye-bye.